want to go over it?
2,
5. Any others? Put phones away. Please. Caleb. Gianna. Okay, number 2, which points are solutions to the inequality graph below? So if you were to plot these points, 0, 3, negative 2, 4, and 5, 1. The only one that falls in the shaded area is this one. This one falls on the line and it's dashed, so that would not work. So that is the only one that is a solution. Questions on that? Number 5, what is the equation of the line if 3, 2, and 2, 0 are points on the line? We have this graph. So if I were to plot these 2 points, 3, 2, and 2, 0, I could find the slope of these 2 points. This would go up 2 to the right 1. And then if I continue that slope but backwards, it would go down 2, left 1, as many times as possible. I'd run into the y-axis to get my y-intercept of negative 4. Then I could put those two together in an equation. Y equals 2x minus 4. Questions on that? Yes.
Can we do number 1?
Yeah. Gianna, were you about to ask a question?
no.
Okay. I just realized some of the number ones should have this line, some of them don't. I don't know what happened there. So if you have the line, if not, you could attempt to draw it. If we're looking for the slope, we need to find 2 points that would cross the grid lines exactly. I'm going to start at this point, and I also feel like this is a little off, but let's say that's cool. And I'm going to count from one point to the other. It does not matter which way. Up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to the left, 1, 2, 3, 4. So that would be a positive 9 over a negative 4, or negative 9/4. Questions on that, or other questions here? Today we're going to start the second lesson in our transformations, but you need your calculator, so go grab that. Graph the function that's given. We're going to y equals, I'm going to actually just reset my whole calculator. Second plus 7. If you want to reset it, that's fine. If you don't have things in your y equals, you can just go in there. I had a bunch of stuff and I forgot. And we're going to graph x squared. Going to y equals height x squared. The f of x that you see is the same thing as y. So we don't have to change that. It means the same thing. We're going to go into the table. Second graph. Very similar to what we did last unit in quadratics. Find where your y values repeat and find the middle, which would be what?
0,
0, 0. That's your vertex, so go ahead and start there. And then graph as many points as you can on this graph. So negative 1, 1, 1, 1. Negative 2, 4, and 2, 4. The next points would be off the graph, so this is fine. So when we talk about the parent function, the quadratic x squared, this is what it looks like when nothing else happens. When nothing is changed, yes. This should be, it should have been under this. Now we're going to do a bunch of different things and see what happens. So I'm going to keep this in my calculator so I can compare it to all the other ones. Go back to y equals in your next line. Change it to the first box. So x squared plus 2. And then graph it. Don't look at the table, just graph it. So yours, you'll just see two different black lines. But if this blue line was the original, and the red line is what we just put in, what happened? What did it do?
It moved down.
It moved down, it moved up. The original moved up.
Look at that. You just that, right?
And we could say it moved up 2. So that would be the change you see, yes.
Can you demonstrate that again?
Mm-hmm. So you put the 2, you already have 1, you put this one in, and then you graph it. So the change, the original, the parent function moved up 2, but the rule, and we'll talk more about this on the next couple pages. This was a vertical shift up 2. Yes.
I'm getting error when I try to graph it.
Let me see. Let me write this and I'll check it.
Yeah.
I did that.
Yeah, those two. Okay. We got this plot.
So then we're going to change the function we had to now minus 2. What do we think that one's going to do? Yeah, so change that to minus 2, and then graph those and see what that one does. And as Savannah said, it did move down 2. So anytime we're moving up or down, that's vertical. So we can talk about how it changed what we see happen, but when we talk about the actual rule, we have to talk about these specific words. What direction, what type of transformation, what direction, and how much. So then we're going to do the next one. Keep the parent function, but change it to this. And let's see what happens. Did you still need this? Yeah. So I'm just going to clear this out and then retype it in with parentheses. X plus 2 on the outside squared. And then graph them. What happened?
Move to the left.
Move to the left. The original moved to the left. We can say it moved left 2. That would be a horizontal shift, left 2. So we talked about this briefly with the vertex. The stuff on the inside does the opposite. So when we go to write the vertex, this would be a -2, and this is why, because it really moved to the left. The inside things do the opposite of what you think. So then this next one is going to do what? Move to the right. So I'm going to write that, but then we can graph it and double check it. And in the graph, I'm going to change that plus to a minus and see what happens. And to the right, the original moved to the right. Questions so far on how vertical and horizontal shifts work? Things are going to change. Now let's type this 2x squared. And graph that and see what changed. Yeah, it got thinner. So we'll just say that got thinner, smear, in either or. This is called a stretch. Go back to the graph. This is vertically stretching towards the y-axis. So the closer it gets towards the y-axis, the thinner it gets. So what do we think the next one might do? Get wider. So I'll graph that first. So if you type in alpha, white equals, that'll change that to a fraction. And you can see it getting wider. That's a vertical compression. It's going away from the y-axis, so the further away it gets, it's compressing. Right? Write that, and then the bell will be ringing. The shift, the word shift, or you may see the word translate, which just means it was moved. So, any of those. So you might see it as shift or translated. Things like these two, you may see vertical stretch. By 2, you may see it say by a scale of. Those just mean the same thing. Right. Then we're going to see what happens when we put in this negative x squared. Make sure it's a negative, not the subtraction sign. And go ahead and graph that and see what happens. Like flips. So we can say it flips upside down. This is called a reflection. And you might see it one of two ways. Written as a vertical reflection. So it's doing this, so that's vertical. Or you can see it as a reflection over the x-axis. So it was sitting on the x-axis and it reflected over it. They both mean the same thing, but you may see either or. So vertical reflection or reflect over the x-axis. Those are basically, we'll talk about, I think, one more transformation, but those are basically all of your different transformations. You have your vertical shifts or your vertical translations, your horizontal shifts and your horizontal translations, your vertical stretches and compressions, and your vertical reflections. Now these are just mixing them, and we have to figure out what would change based on the rules we know / looking at the graph. So let's look at the graph first, and then we'll try to do it without the graph, but you'll always have it. Go back to negative x, what was it? Plus 1 inside parentheses squared. And go ahead and graph that. What happened with that? What changed? It shifted over to the left one, and
Weird.
it flipped upside down. So it did two things. So move left one. That would be a horizontal shift to the left one. Or a horizontal it was horizontally translated left one. And it flipped upside down. And that would be a vertical reflection, or a reflection over the x-axis. Without graphing this one, you can graph it to confirm, or we'll graph it afterwards. What do we think these two things would do, based on the things we have in our table? The 3 would do the same thing that this would. It would get thinner. The 2 on the outside would do the same thing as the second one, moving down 2. You can also say narrower. So it got narrower and it moved down to, shifted down to. So then if we were labeling the rules for that, what would narrower, thinner, what would that be? What would that rule be? So it would be a stretch, a vertical stretch by 3. And then the move down to, what would that rule be? Vertical shift down. And then once we get that, I'll graph it just so we can see that. And then we're going to try again to do this without graphing it. But again, you will always have the calculator. You can always look at it and actually see what happened. So I can see that it is definitely narrower and the vertex moved down too. So if you're confused as to what to look at the vertex and see how that moved. Right. There are 4 things that happen to this. What are those 4 things? Try to compare it to the rest of the table. It would get wider. Which one would tell you that? The 1/3. So that would be, what would that rule be for the 1/3? Compression by 1/3. Vertical compression. I'm going to shorten up this column. Right? 3 other things. It did flip upside down. Which one tells you that? The negative. So that would be what rule? Vertical reflection, or reflection over the x-axis. Right, 2 more things. Something on the inside of the parentheses. Look what happened when there was something on the inside. Move to the right. How much? 3. What would that rule be? Horizontal shift, right 3. And then the last one. And move up 1. And what would that rule be? Vertical shift up 1. So the goal eventually is to know how these work without really using the graph. Of course, you can still use the graph, but being able to look at something and say, this is a reflection, this is a shift, it's horizontal shift, it's a vertical shift, it's a compression, it's a stretch, X, Y, Z. Do you have any questions about this so far? We're going to do something similar, but with a different parent function. And then after we finish this will be the last thing we do today. So this will move a little bit faster because the transformations are the same. We're just using a different function. So on that, we have this function. This is your absolute value of x. In your calculator, go ahead and clear out anything you have there. And to get your absolute value, type alpha window, and you should see something that says ABS. Click that one. So alpha window, ABS, that one. Put X in there. And then go to your table, second graph. Just like your quadratic, the vertex, how we find the vertex is the same. because there's going to be repeating y value, find the middle. Where would that be? 0, 0. And then graph all the other points. What's nice about this is when we get into graphing, we'll talk about it more later. Really, it's just going up 1, right 1, so all of these points are going to be the same. And they're going to mirror each other just like the quadratic, yeah.
How do you get those two lines?
Out the window. And then the ABS. So when you plot all of these points, your graph looks something like this V. So your parabola is your quadratic is a parabola U shape. Your absolute value is a V shape. So you lazily draw graphs, try to make sure one looks like a V, one looks like a U. If I were to add 2 to the end, what do we think this would do? Move up 2. And that rule would be vertical shift up 2. If I had 2 on the outside, that would be, or minus 2 on the outside, that would be down 2. Vertical shift down 2. Inside the absolute value plus 2, what would that do? Move to the left 2. Does the opposite of what you think. And what would that rule be? Horizontal shift left 2. This is missing. Anyway. Inside the absolute value, x minus 2. We move to the right 2. And that rule, horizontal shift right 2. Two outside the absolute value. It would get thinner or narrower. And what would that rule be?
Sure.
Vertical stretch by 2. One half outside the absolute value. It does get wider. And what would that rule be? It's a compression. It's still vertical compression by 1 half. Negative outside the absolute value. It would flip it upside down, so it would be upside down. We're going to talk about this next one. What would that rule be? Vertical reflection, or a reflection over the x-axis. Okay. Watch me graph this one and look at what happens. I'm changing the thickness of the line so you can see it overlap. It's going to overlap, but it's hard to see, but the red line graph right on top of it, it did have, it's on the inside, so things on the inside are horizontal, things on the outside are vertical. I'll repeat that again later. It did a horizontal reflection, but it did this. So it looks the exact same. Something did happen, but it looks like nothing changed. So the change is nothing, but there is a rule for it. So this would be a horizontal reflection. Let's talk about these changes and rules, and then this, and that'll be the last thing we do today. There are two things happening here. What would that change? What would those two things change? You put it in the graph or look back at the table. Would it get thinner? This would be the same as like this. So it would get wider. Now, if this was on the inside, that would be true, but it would go up by 5. So it's outside of the absolute value bar, so it's going to go up. So what would those two rules be? Vertical compression by 0.25, and the other one? Vertical shift up 5. Yes. Right. What about the next one? Flip. It did flip. And it moved right 7. So what would be the rule for flipped upside down? Vertical reflection. That's on the outside, so vertical reflection. And then the other rule? Horizontal shift, right 7. What happened in the last one? Would it get wider? So compare it to the other ones. Would it get wider?
No.
It would get narrower because it's the 5. What else? What?
Left.
It did move left. It shouldn't flip. And
Move down.
move down 1. So the narrower, that rule would be what?
Be stretched.
Vertical stretch by 5. The move left 2 would be what?
Horizontal shift.
Horizontal shift, left 2. And then the last one?
Vertical shift down.
Vertical shift down 1. when we actually get into the practice, and if you want to look at what that might look like, once you know all of what it would look like, you're going to be given different transformations, and you're going to have to put the equation together, but we'll talk more about that next class. Now, we talked about these different things. So this first one is going to be normal. What would this do? It would what? It would flip. And it would go to the right too, correct? And those two rules would be
Vertical reflection.
vertical reflection and horizontal shift right to. Make sure we're specifying all of those things. I'm going to put this in with the original, and we're going to see what happens. So when I look at this, if I were to just look at this and didn't see the equation, what would you think happened? Okay. So if I'm just looking at this graph, it looks like it just moved to the left too. But if I look at the equation, there's a negative in there. So what happened is it moved to the right too, because that's what the x minus 2 would do, and then it flipped horizontally. But it's hard to see that unless you're looking at the equation. So really, it could be both. Now, if you have the equation exactly, then you should do whatever the equation says. But if you just have the graph, it could be either or. So I'll write what it actually did, but then I'll also write what it looked like it did. So it looks like it moved to the left tube, which would be a horizontal shift left tube. But what it actually did would be move to the right and was reflected. So that would be your horizontal shift right to and your horizontal reflection. So if you got something like this and it asks about the transformations, if you see the equation, you should do whatever you see. But if you were given the graph, either answer could be right. Horizontal reflections work weird. But if you had parentheses, then it would be this. You would see that in the graph. I'm not going to give you one to practice today only because we haven't gotten to the actual practice piece. But if you still have your domain and range notes, you can be practicing that. You guys do have a Delta Math on that that's due this week. So we're not really going to use domain and range a whole lot more, so you need to be practicing that stuff so you don't lose it. If you need to finish the test or want to work on retake work, you can also do that during the time.